Welcome to today's math lesson. If you will make your way to Schoology and to this week's folder and then to today's folder, you will see an assignment for lesson 5, session 4. So we're continuing with the same type of work that we did yesterday. You're going to write and evaluate numerical expressions involving whole number exponents, and then you're also going to use variables to represent numbers and write expressions when you've got real world problems or mathematical problems. So in your textbook or just here on the screen, whichever way you're working that's, you see an example problem. And in this example problem, what this person had to do was take these numbers and symbols and create an expression that was going to be equal to 36. So this person said, I know that 6 times 6 is 36, so that'll take care of my square here, or my power of 2. So everything inside the parentheses needs to equal 6, and then I will square that. So they know that 8 divided by 8 is 1, and then if you add 5 plus 1, you would get 6. So they wanted to do, they wanted to do 8 divided by 8 plus 1, not plus 1, plus 5. 8 divided by 8 plus 5. That would give them 6, and then they would square that to get 36. So that is an expression that would be equal to 36 using those numbers and symbols. I want you to try these problems on your own and then come back to the video to check your answers. So pause the video and then come back after you have had a chance to work these. So looking at these problems, with number 1, we have an expression, and the expression is right here, and we have a power. This is to the third power. So it means we're going to take that number and we're going to multiply it 3 times. Not 3 times that number, but that number multiplied 3 times. So we would have 1 times 1 times 1 is 1. This is a decimal number, so we count up our place values that are decimals. We have 3 of them. So we need 3 decimal place values in our answer. We fill in zeros where they belong. So our answer here is going to be 1/1000th. For number 2, when we have a shape like this and we want to find area, we have to divide the shape. We have to decompose it first. So if I decompose this right here, I now have 2 shapes, and I can find the area of each of those and then add them together. So the area of my first shape is going to be x times x. Well, if I have something that I'm multiplying times itself more than one time, I can then use powers. So x squared is the same thing as x times x. And then my other part of the shape, I would do 4 times 3 to find the area. Well, that is 12. I would add those 2 areas together, so x squared plus 12. This would be an expression that if I plugged in a number for x, I would find my area for the entire shape. The problem does tell us that it wants us to find the area if x equals 6. So 6 squared plus 12. This is 6 times 6. 6 times 6 is 36. Then we want to add 12. And that gives us 48. And this is meters squared because we are talking about area. Remember that as you go through these problems, please pause as you need to figure out what you've done wrong. All right, for number 3, we have an expression, and they want us to substitute a value for a and then substitute a value for b. So we have 2 plus b times a squared plus 4. So A is going to be 2, so that's 2 squared plus 4. B is going to be 4. Let me bring down our other pieces to our equation. Or not equation, sorry, expression. So now we're following gems. That should be a G. So gems, groupings is where we start. Within that grouping, we have an exponent, so we start there. 2 squared is 2 times 2, which is 4. Bring every other part of your expression down. Still have that grouping symbol, so I have 4 plus 4, which would be 8. So I'm going to multiply 4 times 8 next, because I've done my grouping symbols, I've done my exponents. Now it is multiply or divide. So this would be 32. 2 plus 32 would take care of my subtraction and addition, which would give me 34. Now it says that Zara chose D as the correct answer. How might Zara have gotten the answer wrong? So D is 48. So I need to look at my steps and decide, is there anything where I have some factors that would equal 48? Because I do have multiplication. So let's start there. I see an 8. So I know that 8 times 6 would be 48. So I wonder if Zara did 2 plus 4 and got 6 and then multiplied 6 times 8 to get 48. So that was probably Zara's mistake. Next we have number 4. And in number 4, you're just going to plug in a 5 anywhere you see M, and then figure out if that expression would equal 100. So 5 squared would be 5 times 5, so that's 25. 25 times 2 is 50. 50 plus 50 is 100. For B, if I plug in a 5, 2 times 5 is 10. 10 squared would be 100, plus 50 would be 150. That would not be equal. Then we have C. If I plug in 5 here, that would be 5 plus 5, which is 10. 10 squared is 100. If I plug in 5 here for D, then I would have 5 cubed. 5 times 5 is 25. 25 times 5 would be 125. And then I would have the rest of my symbols and numbers. So I would do division first, which would give me 25. 25 times 4 would be 100. You can think of it like money. If you have 25 cents and 25 cents and 25 cents and 25 cents, then you have $1, which would be your 100. So then for E, we have a 5 in the place of M. 5 squared is 25. 25 times 4 is 100. For this one, if we replace M with 5, we have 4 times 5, which is 20. 20 squared is not going to give us 100. Then we have number 5, and it says write 3 to the 8th power as a power with a base of 10. So luckily for us, 3 is a factor of 9, so that's going to help us out with this particular problem. So for this one, if we wrote this as multiplication, we would have 3 times 3 times 3 times 3, so that's 4 times 3, 5, 6, 7, and 8. Well, right now that is a base of 3 with 8 as the power. We want to change the base to 9. Well, I know that 3 times 3 is 9. So every time I have 3 times 3, I can replace that with a 9. And then if I wrote this as a base of 9, I would see how many times I multiplied 9. 1, 2, 3, 4. So it would be 9 to the 4th power. For number 6, it says, what is the value of the expression? And then it says when x equals 30. So you have this expression here, and you are replacing x with 30. So 30 to the 3rd power minus 1,750. Well, if we do 30 times 30 times 30, then we would have 30 times 30 would be 900. 900 times 30, well, 9 times 3 is 27, and then you have 3 zeros. So it would be 27,000 minus 1,750. So when we do that, we are going to get 25,250. So that is how we evaluate or find the value of the expression when we are given the value of 30 for x. Let's take a look at number 7. So number 7 says, what is the value of the expression? And it gives you the expression there to solve. So if I'm following GEMS, which is what I want to do when I'm evaluating or finding the value of an expression, I want to start in my grouping symbols. Well, we've got brackets, we've got parentheses, and then even within the parentheses, we've got exponents. So we want to start there. So we have 3 squared, that's 3 times 3, which is 9. We want to bring down everything else in the problem. All right, so I'm not done with my grouping symbol, so I don't move on to my next exponent just yet. So I have 9 minus 7. 9 minus 7 is going to be 2. Anytime you have a number next to a number that is in parentheses, you're multiplying. So 4 times 2 is 8. Sorry, I forgot to bring down the rest of my expression. Brackets work the same way as parentheses. All right, so I have taken care of my grouping symbols. And then I move on to exponents. So I have 4 squared, which is 4 times 4, which should be 16. And then, again, this is just like parentheses, so I am multiplying. So I want to multiply 8 times 8. Well, 8 times 8 I'm sorry, guys. I don't know where I brought the other 8 in. This is a 3. I should have brought down a 3. That should be a 3. That should be a 3. So we're doing 8 times 3 and then subtracting 16. So 8 times 3 is 24. So we have 24 minus 16. All right, so 24 minus 16 would give us 8 as our value. All right, number 8. There are 32 teams in the first round of a basketball tournament. 1/2 of the teams that play in each round of the tournament move on to play in the next round. Explain why the expression 32 times 1/2 to the 3rd power represents the number of teams that play in the 4th round. Okay, so the number of teams in the 2nd round is 32. times 1/2. The number of teams in the third round is 32 times 1/2 times 1/2. The number of teams in the fourth round is 32 times 1/2 times 1/2 times 1/2. So, what all that means is we start off with 32 teams. The first round is 32 teams. For every round after that, 1/2 of the team can play. So round 1 is 32 teams. Then we have half of that in the second round, half of that in the third round, half of that in the fourth round. Well, because we have this repeated multiplication of the same number, 1/2, we see that it's being multiplied 1, 2, 3 times. So this is where the exponent comes in, and it is 32 times 1/2 to the third power. And then B, how many teams play in the fourth round? Show your work. So in this case, you're actually evaluating that expression. So 32 times 1/2 to the third power, right? So we're doing 1/2 times 1/2 times 1/2. When we do that, we multiply straight across the top. That would be 1. Straight across the bottom, 2 times 2 is 4, times 2 is 8, so that would be 1/8. So we have 32 times 1/8. We can place the 32 over 1, and then we have 32/8, and we can divide. 32 divided by 8 is going to give us 4. So 4 teams will play in the fourth round. Number 9, the value of 2/14 is how many times as great as the value of 2 to the 11th power. I should not have said 2/14. 2 to the 14th power is how many times as great as 2 to the 11th power. So 2 to the 14th power has 14 factors of 2, and 2 to the 11th power has 11 factors of 2. There are 3 more factors of 2 in 2/14 than 2 to the 14th power than 2 to the 11th power. So 2 to the 14th is 2 times 2 times 2, or 8 times as great as 2 to the 11th power. So here, you're focusing on the powers. So 2 to the 14th power and 2 to the 11th power. When we multiply, we're just multiplying times 2 times 2 times 2 times 2, right? And we do that as many times as we have this exponent. Well, this exponent is 14. This exponent is 11, right? So the difference, 14 minus 11, that would give us 3. So there are 3 times that we're multiplying 2. So we multiply this 2 this many times more when we're doing this one. So 2 times 2 is 4, times 2 is 8. So it's 8 times greater. All right, number 10 is similar to the problem, the example problem. So if you want to go back and take a look at the example problem, do that. But I want you to do number 10 on your own. Just remember that you do want the expression here to equal 8, and you want to use these. So keep that in mind as you're working the problem and see what you come up with. Don't forget when you're done to submit your assignment. And that completes today's math.